Okay, so now we're going to take a look at a system head curve. We all have studied the paper now, so we know that there is a lot of things on the system side that will start to generate this curve, the suction piping, discharge points, and anything that resists the flow rate. So let's take a look. This is a spreadsheet that was created. It's using formulas based on the Cameron hydraulic manual. These are common formulas, and they give you friction loss per 100 feet, and the spreadsheet's basically done so it does a lot of self-calculation for you to help make it as easy as possible. So the first thing we're going to do is we've got about 300 lineal feet of pipe. The C value is a value for the roughness of the pipe. Since we're almost always seeing PVC pipe, 125 is a good median number. It could be as high as 150. The higher the number, the smoother the pipe. We enter in the nominal pipe size, and then we entered in the information taken directly off of the manufacturer's pump curve. Now this is the same curve we've been looking at with a design condition of 1000 GPM at 68 feet. So from the curve we got the different flows and the corresponding head at each of those flow rates. We put in a required head of 28 feet, which is roughly 12 psi. Differential elevation's about 12 feet. And then we entered in the approximate number of fittings. If we had an exact number, we could probably get this a little bit closer, but for right now, this will work. So all of this information is calculated, and then it starts to generate information in this gray table down here. You'll notice that the pipeline friction loss, H sub F, is the acronym for friction loss, or head friction, if you will, and the fittings. The velocity is 0 because our flow rate is 0. We have 80 feet ahead, and so as we start to flow water, then the restriction to flow starts to increase slowly. The velocity increases, and as you can see, from 400 to 600 to 800 to 1000, it starts to jump. And it continues to climb all the way out to 1345, which the manufacturer says is the max limit that they want to see. So what it looks like, this is a generated pair of curves. So here's the pump data curve that's been generated from the information above, and here's the system head curve. Where the two cross is the approximate operating point. So you can see it's pretty close to what we expected to see. Now let's take a look at the manufacturer also had a feature on their software that would allow us to put in a system head curve. We gave it what they called static head of 40 feet. And it took the static head and our design point, and then it interpolated a nice smooth curve, which is pretty accurate in terms of what's actually going to happen. But there you can see it laid across the actual performance curve from the manufacturer. Now, let's take a nice interesting look. You can see where our total head is when we have what we refer to as a dirty filter. If I take away the required head and change that to 0, then our curve is going to adjust now. And you see it drops way down, moves almost out to the maximum flow rate. So that should be a good indicator, and this would be our clean filter system head curve. I want to keep those two terms in mind because we're going to take a look in the next video at how the smart pump control system works and how the pump works inside of the system head curves that we're looking at.